So he has given a function with two independent variables, and he is asking the function is having maximum or minimum values at its stationary points. Okay, first of all I'll find out the stationary points, then I'll see whether the function is having maximum or minimum value. So first of all I'll find out p, small p. P is nothing but dou f by dou x. It's all partial integration, partial differentiation. So this is how much if I do with respect to x, this will become 6x square plus 6x. Similarly q is nothing but dou f by dou y. So with respect to y, this will become 6x plus 6y. And similarly r is nothing but dou square f by dou x square. So if I do with respect to x once again, I'll get 12x plus 0. Sorry, this is not x, this is y. And similarly s is nothing but dou square f by dou x into dou y. So you do with respect to y. The first p you do with respect to y. So when you do with respect to y, this is 0 and this is 6. Similarly t is nothing but dou square f by dou y square. That means you do partial integration q once again. So if you do partial integration with respect to y, it is 0, which is 6. So after this, in order to get the stationary points, the condition is you have to make p equal to 0 and q equal to 0. So that means 6x square plus 6y equal to 0 and 6x plus 6y equal to 0. If we solve this, I'll get 6x square minus 6x 6x I'll take common, x minus 1 equal to 0. That means x equal to 0 or 1. So if x equal to 0, and what about y value? Y value is 0. So that means the stationary point is 0 comma 0. And if I substitute x equal to 1, I'll get, so you have to substitute these values in these equations. So if I substitute x equal to 1 from the equation 1, this implies 6 plus 6y equal to 0, this implies y equal to minus 1. So that means the stationary point one more is 1 comma minus 1. So I got two stationary points, one is 0 comma 0 and other is 1 comma minus 1. These are the two stationary points. Now I want to know whether these stationary points is having maximum or minimum values. So in order to find that, I have to calculate RT minus S square. So RT minus S square, RT minus S square. So this is equal to, RT means R is 12x, so 12 into 0, I am calculating at 0 comma 0. So 12 into 0 minus S value is anyway 6, so this is 6 square. So this is minus 36, which is less than 0. So whenever you will get RT minus S square is less than 0, so that means it is a saddle point. No maximum, no minimum. It's a saddle point. Similarly, I'll find out at 1 comma minus 1. So at 1 comma minus 1, RT minus S square. So this is equal to, R is 12x, so 12 x is 1, this is r, s is 6, sorry, t is 6, minus s square is 6 whole square. So this is 72 minus 36, so this is 36, which is greater than 0. So whenever you have rt minus s square is greater than 0, that means it is having minimum value. So that means 1 comma minus 1 is a stationary point which is having a minimum value. So from the given options, the answer is D.